All right, so in this video, I'm going to go over the 4.2.3 practice. This is an ungraded activity, but in this activity, there's some great examples on how we use a random number table and your graphing calculator in order to produce random samples. And I actually want to do this a little bit backwards. I think the best question to start with is number 5 in this um, activity. So again, this is 4.2.3 in Apex if you want to print it out and follow along. So on number 5 here, it says the subjects below are participants in an experiment on the effects of tutoring on academic performance. Half the subjects will receive enhanced one-on-one tutoring. The other half will receive group training. Describe how you'd use the TI-83 or TI-89 to randomly assign the subjects to the two conditions. Indicate what subjects are placed into each condition based on your scheme. And then it says part A, use your graphing calculator. And I think it got cut off there. I think they do also want you to use the random number table. This random number table here is provided in this activity also. So again, this is 4.2.3, and this whole table, and there's actually an additional page of this table, is all in that practice assignment. So first of all, let's remind you how to do this on a graphing calculator, which I've already done before in the previous video. So for the most part, in your exam, your AP exam, if you're asked to describe how you would do something, how you would generate a random sample, they're wanting you to describe it using the table, not the calculator. But if we wanted to use our calculator here, the first thing that I would need to do is I would need to describe how I am going to assign numbers to all of these participants. So there's 30 subjects here, so I'm going to assign the numbers 1 through 30 to these participants. So I can call this one participant 1, participant 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So if I needed to describe this process, I would actually need to write the sentences down and describe what I just did. I numbered each of my participants 1 through 3. That's the first step. Second step then, in our graphing calculator, we click the math button, move over to numbers, and we want, or no, move over to, goodness, I forgot where it was. Random integer. Oh, there it is. So you hit the math button, move all the way over to PRB, and then go down to option 5. RANDINT stands for random integer. When I click enter, it just puts it on my screen, and what it's asking me to give them now is the range of numbers from which I want a random number to selected. So I would put in that I want my number to be between 1 and 30. So 1, 30. Close my parentheses and hit enter. It will give me one random number. So I need, how many? I need half the subjects are going to get one-on-one tutoring, and half the subjects will receive group training. So half of 30 is 15. So I would click my enter button 15 times to produce my random sample of size 15. Now with those 15 that I just calculated with my calculator, those 15 numbers that I just found are going to be the people that are going to get the first treatment, which is one-on-one tutoring in this case. So the 15 participants whose random numbers were chosen will receive one-on-one tutoring, while the remaining 15 will receive group training. And there we go. We've just randomly assigned 2 treatments to a group of 30 individuals using our graphing calculator. Now let's talk about how we do the same thing using this random number table. So the first thing, in order to use a random number table, I am going to number my participants like I did before, but all of my numbers that I assign need to have the same number of digits for this to work. So going back, the most digits that any number has is 2. Numbers 10 through 30 have 2 digits. So I need to adjust numbers 1 through 9 so that there are 2 digits there as well. So I'll change 9 into 09, change 8 into 08, and so on, so that every number on my list now has 2 digits. So when I write that as part of my response, I say that I'm numbering my participants from 01 to 30. It's important that I have the same number of digits for all of the numbers in my study. The next step is looking at my random integer table here. And there is a random number table in the back of most textbooks for Apex. It is in the resource tabs, but of course this again is in 4.2.3 and you're welcome to print it out from there. So the key things when we're using a random number table is we always want to start in a random place. So I would just kind of randomly select a line to use here. So perhaps I want to use this line right here, line 15. Okay, for no particular reason. Now what I'm going to do, since my participants were assigned 2-digit numbers, I'm now going to look at every 2-digit number on this line starting at line 15. So that would be 11, 60, 06, 74, 96, 04, 81, 19, 19, and so on. And while I'm doing this, I want to look for any number that is in my set. Remember, our set of participants are numbered from 01 to 30. So not every single one of these 2-digit numbers is between 01 and 30, but we're going to look at them anyways. I'm only going to include the ones that are in my study, and if there are any repeats, I'm going to disregard them. So the first number I see here is 11. I have a number 11 in my study, so that's my first pick. The next number is 60. My study only has 30 participants, so I don't have a number 60, so I move on. The next number is 06. I have a 06, so I'm going to include it. The next number is 74. I don't have a 74, so I move on. I also don't have a 96, but I do have a 04, and I haven't counted them yet. So at this point, I have included in my first treatment numbers 11, 6, and 4, which are Ford, Taylor, and Collier. And I'm going to keep doing this until I get a simple random sample of size 15, just like last time. And I'm going to assign those 15 people to the first treatment and the remaining 15 people to the second treatment. So if I continue this, let's see, I have 1, 2, 3 participants so far, keep going, 19. And again, I get a 19 right here. Since I already included 19 in my study, I'm not going to include it twice. I'm not going to give this person a treatment 2 times. So I'm not going to include that number. Okay, moving on, 30, we have a 30. And then we have 90, 02, 89, 22. Haven't included a 22 yet, or a 28. 88 doesn't work, 95 doesn't work. 02, we already included a 02 over here, so I'm not going to include that. 23, I have not included a 23 yet, so we'll include that one. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I keep going. No 42, no 86, no 58, no 57, no 98, no 89. 13 is between 1 and 30, and we have not included it yet. Keep going. We don't have a 32, we don't have a 97, we don't have a 60, we don't have a 67. Scrolling over. There we go. We don't have a 77, but we do have a 16. Have we included that 16 yet? No, we have not, so I include it. Next is 36, 8807. Have we included a 07 yet? No, we have not. Now at this point I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 participants. I still need 3 more. 40, 04. I already included 04 here, so I can't include it again though. Next number is 18, which we have not done yet. 52 is not in our studies. We don't have a 78. We don't have a 90. We don't have a 70. No 59. No 89. 09 would work. Have we included it yet? No, we have not. So we only need 1 more. 90. 20 is between 1 and 30, and we have not included it yet. So using this random number table, starting randomly at line 15, we ended up with a simple random sample consisting of the participants numbered 11, 6, 4, 19, 32, 22, 28, 23, 13, 16, 7, 18, 9, and 20. And the remaining 15 participants are going to get the other treatment. Okay, so how do we write down to describe what we just did? So as I already said, the first step was to number our participants from 1 to 30. After that, we began at a random point on the random number table. That's super important that we say that. Then we want to select the first 15 unique 2-digit numbers that are between 0, 1, and 30. Unique here means that we skipped any number that we had already included in our sample. 2 digits means we're all looking at every single 2-digit number, even if it's not necessarily in our range, but we're only selecting those ones that are in our range between 0, 1, and 30. And then again, that group of 15 that we end up selecting receive one of the treatments, while the remaining 15 subjects receive the other treatment. The rest of the examples in this 4.2.3 work very similarly. In number 4, it says a researcher is interested in examining the effect of various fertilizer on the growth of plant seedlings. She has 200 different seedlings and wants to randomly assign them to one of 4 conditions: fertilizer A, B, C, and D. Describe how you'd use a random number table to complete the random assignment. This is basically the same as the last one, only instead of having 2 treatments, we have 4. So out of 200 seedlings, if she distributes these evenly to these 4 treatments, then she would need 50 seedlings assigned each treatment. 50 seedlings in fertilizer A, 50 in fertilizer B, 50 in C, and 50 in D. So she would do the same thing we did before. Since there are 200 seedlings, she would need to assign these seedlings the numbers 1 through 200, or 001 through 200 if we're using a random number table. Then she would choose the first 50 numbers to come up either on the calculator or from a random point of the random number table that are unique and within our boundary from 001 to 200. Then she would choose the next 50 and then the next 50 again for the second and the third treatment. And then any of the remaining 50 would get fertilizer D. This number 3 is a little bit different. Instead of generating an actual sample from a real population where we have actual numbers to work with, we're kind of theorizing here. It says describe a procedure to simulate drawing a sample of size 30 from a population which has a probability of 0.33 of having some trait. And it gives a hint here. It says, hint, in a sample of 30, roughly 10 individuals should have this trait. That makes sense because if there's a 0.33 probability of having a trait, that means 1/3 of the population has the trait. So we want to create 5 different samples with a random number table and with a graphing calculator here. After we've done that, we're going to answer these questions. How many samples in each instance have P equal to 0.333? So in other words, looking at our samples that we end up producing, how many of them actually have a 1/3 with that trait? Part B says, describe how you'd use a random number table to select sample members from the population And part C says describe how you'd use a graphing calculator to select sample members from the population. So we're going to describe how we would select our samples, and of course we're actually going to get those samples, show those samples, and count how many of them have this correct proportion. So to do this, we have to assign our population some numbers and then select those numbers from either a table or a graphing calculator. So I need to think about what's the easiest way to assign numbers to a population of any size and have a third of those have a certain trait. And this is the easiest way to do that. If I use the random digits 1 through 9 for my population, then again, a third of those would have the special trait we're looking for. Well, out of 9 digits, a third of that would be 3. So we're going to suppose that the integers 1 through 3 have this trait. Then, when I select my random sample, I know any 1, 2, or 3 that ends up in my sample has that trait. And because all digits are going to be 1 through 9, I know exactly 1/3 of the population I'm selecting from has that trait. So in a graphing calculator then, all I would do is go to Math, over to PRB, option 5, randint, and we would want an integer between 1 and 9. So we want samples of size 30, and they wanted 5 of them. So I'd hit the enter button 1, 2, 3, 4, 5, 6, 7, 30 times, and count the numbers of 1, 2s, and 3s in that sample to get an answer to see if it truly was a proportion of 1/3 within the sample instead of just the population. For the random number table, we would do pretty much the same thing. As always, we want to select a random point at in the table to start. And now, since we're only looking at single digits, I'm going to look at every single digit and include every number between 1 and 9, meaning the only number we're not going to include is 0. And I'm going to do that 30 times. So we got 2, 2, 4, 6, exclude that 1, that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So in this instance, I'm not skipping numbers that I've already used because the number simply just indicates to me whether or not they have a certain trait. It doesn't necessarily mean that they aren't different individuals. We haven't assigned these numbers to specific individuals, so we're kind of using it in a different way. So out of that sample of size 30, I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers that are 1, 2, and 3. So that's 13 out of 30, which is very, very close to 10 over 30, or the 0.333 that we were hoping to get. This next example here, number 2, is pretty interesting. In this one, we want to actually find a stratified random sample instead of just a regular simple random sample. Remember, for a stratified random sample, we're going to separate our population up based on some kind of trait into different strata. And then we're going to take a simple random sample from each strata. So in this population, it says there are American, European, and Asian doctors. In the original population, it says you have 300 American doctors, 200 European doctors, and 100 Asian doctors. in our sample, we want to have a random sample that is 10% American doctors, 20% European doctors, and 30% Asian doctors. Okay, it does not say though how big our sample needs to be. So the nice thing about that is with percentages, a very easy number to work with is 100. If I make my sample size 100, then 20% of 100 is 20. 10% of 100 is 10, and 30% of 100 is 30. So to make a stratified random sample, the first thing I need to do is separate my doctors up by race, American, European, or Asian. Then in each of those, I am going to number them just like before, from 1 to 300 for American doctors, or 001 to 300 for using a random number table. I would number my European doctors from 1 to 200, or 001 to 200, and my Asian doctors from 1 to 100. Then in my random number table, I would choose the first, I would choose unique 3-digit numbers, or in my calculator, I would use my random integer function. And when we do that, we want 20 from the European strata, 10 from the American strata, and 30 from the Asian strata.